Okay, in examples like this, where we've got sines and cosines multiplied together, we can use an algebraic substitution. And what we're after is, we have standard integrals that we can use. We know what the integral of sine x is. We know what the integral of cos x is. They're standard integrals. The trouble here is that we've got a combinations of sines and cosines. And also, we've not got just sine, we've got sine to the power 5. So the problem in this particular integral is this bit. And as we'll see, and you'll need to note for future reference, is that we can use algebraic substitution in this case because it's multiplied by cos theta. If that cos theta wasn't there, we wouldn't be able to do it. Let me show you how it works. So what do I let u equal? I let u equal sine theta, so that I can then, I've got u to the 5, and I can integrate u to the 5, because it's a standard integral. The integral of ax to the n is another standard integral with respect to x. So the substitution we make is u equals sine theta. So what we do is we let u equal sine theta. And whatever we decide to let equal u, we differentiate. So therefore, and what we're going to differentiate with respect to, if u equals sine theta, what we're going to do? Du by d theta will equal, what's the differential of sine? Cos, just cos theta. Now, as before, we're after changing our integral d theta and making a substitution. So this d theta, we need to rearrange this little equation again, as we did before for d theta. So multiply both sides by d theta, divide by cos theta, and we get d theta equals du over cos theta. So exactly the same process as we've just done in the previous example. So now, the integral that we had before, the integral between 0 and pi over 6 of sine 24, sine to the 5 of theta, cos theta, d theta, that's the original question, equals, take the 24 outside, integral between 0 and pi over 6. Again, constant can go outside the integral. We're letting u equal sine theta, so this becomes u to the 5 times cos theta times du over cos theta. So let's look at this again and how it works. Do you remember I said that the fact that the cos theta is there means this works? So what have we done? We've let the sine theta be u, because I can integrate sine theta, but I can't integrate sine theta raised to the power 5, or sine to the 5 theta. So what I do is I let u equal the sine theta bit and differentiate it. And I know that if I differentiate sine, I'm going to get a cos. So I know before I start that this is going to be the case, and when I rearrange it, d theta equals du over cos theta. Now, when I put that in here, substituting u instead of sine theta into there, I get u to the 5. The 24's come outside, by the way. And note what happens when I make my substitution for d theta. I've got to put in du over cos theta. Now, can you see why this only works? Because that cos theta's there. They cancel each other out, exactly. And that must happen. Remember, as before, it only works if the x disappears. Exactly the same here. This substitution will only work if the variable we had before, in this case theta, is now gone, and we're only left with u's. So this method works because there's a cos theta there that cancels out with our cos theta in the original one. So in other words, the fact that this cos theta is there in the original question means I can use this substitution. If it wasn't there, if it was just integrate 24 sine to the power 5 theta, I couldn't use this method. I'd have to use something else. And I'm labouring this because this is what starts to happen with integration. There's lots of different methods to do it, and you have to recognise the type of question to allow you to do it. So now we can go. The cos thetas cancel out, and so this equals 24 integral between 0 and pi over 6 of u to the 5 du. Because the cos thetas have cancelled. And this is easy. I just add 1 to the power and divide by the new power. So it's u to the 6 over 6, isn't it? Plus c. But in fact not plus c this time because it's a definite integral. So this is 24 times u to the 6 over 6 between 0 and pi over 6. Sorry? Yeah. Yeah, the 6 can come outside, so this equals 24 over 6, which is just 4 u to the 6 between 0 and pi over 6. Because the constant 6 can come outside, right, Andrew? This 6 here can come out and go underneath, so 24 divided by 6 is 4. Okay? And now, as Daniel was suggesting, we can substitute back in what u is. What's u? It's sine theta. So this equals 4 bracket sine to the power 6 of theta between 0 and pi over 6. So now we can put in our limits. Leave a square bracket there because in the end we've got to multiply all by 4, and then we use curly brackets, so it's sine to the power 6 of pi over 6 minus sine to the power 6 of 0. Imagine a sine wave. What's the sine of 0? Well, so what is it? What is the value of it at 0? Where does it start, the sine wave? At 0. It starts, what's the sine of 0? 0, yeah. So this bit, 0. So that bit's gone. As soon as I see that 0, I know that that part's gone. So this turns out to be 4 times sine to the power 6 of pi over 6. And if you remember what this means, actually, this is shorthand for, what we're actually got to calculate on the calculator is 4 times the sine of pi over 6 all to the power 6. That's what that means. So on your calculator, work out what sine of pi over 6 is, and then to the power 6. And that equals 0.0625, not forgetting to put your calculator into radians. Okay, because we're measuring in radians here, pi over 6.